In this video, we looked at factored form of a parabola. So here's an equation, y equals x plus 1 times x minus 1. We're going to look at the graph of this. In order to do that, we'll start with the table of values. The idea here is that we're going to take these x values from the table. These x values can be anything. I just chose values that were close to 0 because they're easy to work with. And we're going to substitute those values into the equation for x. Everywhere we see an x in the equation, we're going to replace it, in this case, with a minus 2. So y equals negative 2 plus 1 times negative 2 minus 1. And we can do the arithmetic here. Negative 2 plus 1 is negative 1. Negative 2 take away 1 is negative 3. So when we multiply those together, negative 1 times negative 3 gives us positive 3. So we do that same process for all the values in the table. Now that you see how to do that, maybe we'll skip a couple of the steps here and we'll just substitute the value in. So we'll look at negative 1. Negative 1 plus 1 is 0. Negative 1 minus 1 is negative 2. 0 times negative 2 is just 0. If we substitute a 0 in here for x, 0 here and 0 here, 0 plus 1 is 1. 0 take away 1 is negative 1. 1 times negative 1 is negative 1. Let's substitute a 1 into the equation. So a 1 in here, 1 plus 1 is 2. 1 minus 1 is 0. 2 times 0 is 0. And then lastly, we'll look at substituting a 2 into the equation. So a 2 here and a 2 here. 2 plus 1 is 3. 2 minus 1 is 1. 3 times 1 works out to 3. We now have a table of values. We can look at the graph of that table, and it looks like this. So we can plot the values. So if we look at this first point, when x is negative 2, that's over here. When x is negative 2, y is 3. So we go up to this point right here, negative 2, 3. We do the same thing for the other points. When x is negative 1, y is 0. When x is 0, y is negative 1. When x is 1, y is 0. And finally, when x is 2, y is 3. Nice smooth curve through the points, and we have our parabola. We can identify some characteristics about this parabola. So in this case, the direction of opening, this parabola opens up. The zeros, so the zeros are where the graph crosses the x-axis, these points right here, and we get that the zeros are 1 and negative 1, so x equals negative 1 and x equals 1. The axis of symmetry, remember, is that line that goes right down the middle, and it has an equation. The equation of this axis here is just x equals whatever the x value of the vertex is. In this case, the axis of symmetry is just x equals 0. And then finally, the step pattern. The step pattern, in this case, we go over 1 and up 1, over 1 and up 3, and so on. So the step pattern here is 1, 3, and 5. So that's a quick look at how to graph one of these equations in factored form. So this form over here is called factored form because there's one factor here multiplied by another factor here. We'll look at a couple more of these just to see what happens, what changes as those factors change a little bit. So here's example number 2. So here's the equation. Y equals x minus 3 times x plus 1. So again, we'll make a table of values, substituting negative 2 into the equation for x. So everywhere in the equation that we see an x, we're going to substitute in a negative 2. So negative 2 take away 3 is negative 5. Negative 2 plus 1 is negative 1. And then we're going to multiply a negative 5 by a negative 1 to get positive 5. Substitute a negative 1 into that equation. So a negative 1 here, a negative 1 here. Negative 1 take away 3 is negative 4. Negative 1 plus 1 is 0. Negative 4 times 0 is 0. And again, we'll have another look, this time substituting in the point 0, or the x value of 0. So 0 here. 0 take away 3 is negative 3. And then 0 plus 1 is just 1. Negative 3 times 1 is negative 3. and on to the next one. So substituting a 1 in here, 1 take away 3 is negative 2, 1 plus 1 is 2, negative 2 times 2 is 4, and the last one here, substituting a 2 into the equation, 2 minus 3 is negative 1, and then 2 plus 1 is 3, negative 1 times 3 is equal to negative 3. So now we can go ahead and graph this. These are the x values of our points, and these are the y values. So we'll start with negative 2 and 5. And I've prepared a graph for you. It looks like this. Whoa, here it is. So when x equals negative 2, I couldn't quite get it on the graph here. So we'll skip that first one. When x equals negative 1, y is equal to 0. That gives us this point right here. When x is 0, y is negative 3. When x is 1, y is 4. Or sorry, negative 4. That should have been a negative 4. And when x is 2, y is negative 3. So you can see nice smooth curve through those points, and we get a nice looking parabola. So let's look at the characteristics of this graph. What direction does it open? This parabola opens up. It has zeros here and here. So the zeros in this case are x equals negative 1 and x equals 3. Where's the axis of symmetry? Well, the axis of symmetry is that line that divides the parabola exactly in half right here. So the axis of symmetry in this case is x equals 1. And again, we're looking for the step pattern. So we're going to go over 1, up 1, over 1, up 3, over 1, up 5. So the step pattern here is 1, 3, and 5. So part of the reason why we're doing this is it would be great to be able to find some kind of pattern that would speed up this process for us, that would allow us to find either the graph or some of these characteristics without actually having to make a table. So I want you to kind of just pay close attention to these numbers here, the zeros, and the equation, which is located just up here. So if we look at the original equation, way up top here, the equation had a minus 3 in it and a plus 1 in factored form. And look at the zeros. So the equation had a minus 3, just like this. And here are the zeros. So notice that the zeros are the opposite of these numbers in the brackets here. And the reason for that is, if you think about it, if we substitute a 3 into this equation, 3 minus 3 will give us 0, and 0 times anything, whatever this number is going to be 0. So that's why the sign of the zeros is just the opposite of this value here in factored form. So let's have a look at the next one. One more example. So this one's a little bit different. Now we have an a value of negative 2. So at negative 2 times x plus 1 times x plus 5. And we'll just substitute our values into the equation. So negative 2 plus 1. So we'll put a negative 2 in here. Negative 2 plus 1 is negative 1. Negative 2 plus 5 is going to be 3. And then we have this negative 2 out front that we have to multiply all of that by. So negative 2 times negative 1 is a positive 2 times positive 3 is 6. And then we'll repeat that process with the other values in the table. So let's just see if we can make some room here. There we go. If we substitute a negative 1 in here, negative 1 plus 1 is 0. 0 times whatever value this is going to be times whatever value this is going to be is 0, but we can put the value in if you want to see. So negative 1 plus 5 is 4, and then we have a negative 2x here, or sorry, a negative 2 here as well. So negative 2 times 0 times 4 is just equal to 0. Let's look at the next one. Substituting is 0. 0 plus 1 is 1. 0 plus 5 is 5. And we get a negative 2 out here. Negative 2 times 1 is negative 2. Negative 2 times 5 is negative 10. And then we can move on to the next one. When x is 1, 1 plus 1 is 2, 1 plus 5 is 6, and then negative 2 times all of that. So negative 2 times 2 is negative 4. Negative 4 times 6 is going to be negative 24. And then the last point on our graph, substituting a 2 into here. 2, sorry, we'll do that here. 2 plus 1 is 3. 2 plus 5 is 7. And then negative 2 times all of this. So negative 2 times positive 3 times positive 7. That's going to be negative 6 times 7, which will be negative 42. So that's getting quite large. Just for fun, why don't we have a look at what happens if we substitute a negative 5 in here for x. So a negative 5 plus 1, and then a negative 5 plus 5. And we're going to multiply all that by negative 2. So negative 5 plus 1 is going to be negative 4. Negative 5 plus 5 is 0. And multiply all that by negative 2. So negative 2 times negative 4 is positive 8, times 0 is 0. And that just goes back to what we talked about earlier. If we substitute a negative 5 in there, we're going to get a 0. Let's have a look at the graph. So the graph looks sort of like this. Oh, I've lost it. There it is. And you can see that we didn't get all the points from here, but we got a few of them. So you can see here a few of the points are negative 2, 6 is here, or negative 1, 0 is here, and certainly the rest of the points didn't go, but we did get this one here, right? So what direction does this parabola open? Well, this one opens down. Why does this one open down when all of the others opened up? What in the equation up here caused this parabola to open down? Well, what caused it was this value right here. The fact that this was negative means that the parabola is going to open down. Again, notice the zeros here are at x equals negative 5 and x equals negative 1. So the opposite of the values in the brackets here. The axis of symmetry is that line that divides the graph exactly in half. And in this case, the axis of symmetry is going to be x equals negative 3, this x value of the vertex. And then the step pattern. So when we look at the step pattern, let's have a look here. We went over 1, and we went down 2. And then we went over 1 and down 6. So the step pattern here is negative 1, negative 6. And if we could check, the other one would be negative 10. The negative just means it went down. The values of 2, 6, and 10 take the standard step pattern 1, 3, and 5, multiply it by this negative 2 in the brackets here, sorry, in front of the brackets, to get these things right here. So that's how we use the equation to help us find out what this graph is going to look like. It's probably worth summing that up just quickly. Here's what the general form of an equation in factored form looks like. The a value will control the, so the a value, if it's positive, maybe we'll abbreviate that positive just to make this a little bit faster. So if it's positive, we get opens up. If it's negative, the graph opens down. And then it also determines the step pattern. Oops. And then these values here are the zeros, the opposite of these values in the brackets. So opposite of these values are the zeros. So that's a very, very quick introduction to graphing in factored form and picking out some of the characteristics.